some of these. So something really weird. So that's not something you could easily just like draw the structure for manually. You could contour and everything, but if I wanted to panelize this and then also start to create the structure for it, that can get really tricky unless you understand kind of how you can start to go about this. So I'm going to set just the surface here in Grasshopper. And what I want to start doing is, let's make just a simple structure for this. So if you grab, let me just copy that guy. That way it's not connected to anything. This is the surface, and the only difference is I've told it to reparameter. This is like the hardest word in the world to say, reparameterize. You can do that by just right clicking. So what that does is it'll just reset any sort of values that it had. It resets them from like 0 to 1. So like if it had some weird sort of like count, it resets the count so that when you start to panelize it, it makes it really clean. A lot of times if you're trying to do something and it keeps failing, check that, because that helps sometimes. It's kind of like resetting it to a new logic. And you need to set something, so I'm going to tell it set one surface and grab that one. Then here in Rhino, I'm going to just hide it and then make that look a little better. So there we go. So kind of to walk you through this, I don't want to show you what it's going to look like at the end, so I'll ruin the surprise. But just like we did last time, we're going to divide the domain first. And I'm going to subdivide this. So divide domain squared. So we're going to grab the surface and then the count, and the U and the V, so we can put in, let's put 30. Remember, if you type a number that's more than 10, less than 100, you'll get a slider from 0 to 100. If we put over 100, like 101, it's going to go from 0 to 1,000. And then if you want decimals, you just put however many points you want. So this one's good for now. We'll do a 30-30. And then if you wanted to actually see those, you can ISO trim them. This step's like kind of extra if you wanted to see how many panels. That helps kind of like visualize it, but it's not totally necessary. This one I can turn off the preview, and then we can use this to help lower or raise this. So let's start with panels that are a little bit bigger like that. So you can see now how this is actually following that shape. So that's the first step. Whenever you're trying to start to create any of these, either a panel or a structure or any of this, you need some sort of logic to how you're breaking up that complex form into simpler shapes. And then right now this is just square, but you could also just you can triangulate these, you can make it in hexagons. There's tons of ways you can do like a panel system. So it doesn't always have to be just rectilinear. You can also do like weird stuff that some people do, but for now we'll stick with just regular, and then we'll get crazy later in the semester. The next thing I want to do is start to this next part of it. Oh, here's another cool thing that I wish I knew when I was like kind of starting off. You can set views just like we can in the 3D model. We can set views in the definition. So once you like at first we were kind of doing small definitions, there are like 3 or 4 things, but once you start getting more advanced and you're doing like big definitions, you'll spend a lot of time scrolling around. So you do have this little map that lets you move around like quickly. But let's say I want to always be able to move my window to here. You can zoom in there, and then if you go here to add name view, you can also do it up here under view, store current view, and we can say this is like, you name it, original panel, and then that's kind of like what it is. And then we can like keep working, we can get over here, and you could be like, oh man, I need to go back. It's going to be saved right here, and if you click that, it just like warps you over. So that's like, if you find there's like key areas of your definition that need to be saved, that's a really easy way to kind of navigate around. A lot of times like you forget to do that, and then you just scroll a lot. So I'm going to use our little buddy list item. So if I put this in here after I've done the ISO trim, you can actually see, so let's put in like 50 so we get a lot of them, the individual panel. So if I turn that off and I move this number around, see, that's going to run through this list, and I can double click this and make the maximum like 1,000, and it will run through that whole list looking for the different panels. So if you turn this back on, it's not actually making a new panel, it does make a panel, but it's identifying one. So where this becomes very useful is when we're trying to work out a definition like this and you're not sure exactly how it's going to work, or maybe you do know how it's going to work, rather than disabling the definition and not letting it run, you can do that a bunch of ways. If we actually wanted to see what's happening, that's a good panel because I can kind of see it nice and clear. What I'm trying to do here is I want to first blow this panel up into its components. So right now it's just like a square. I want to take that and actually extract out all 4 corner points, because a diagrid, what is a diagrid? It's basically you're creating like an X right on every single panel. So if you think of it that way, how could we draw that? And you need to identify points like 1, 2, 3, and 4, and then you connect them diagonally. Right? So that's kind of the logic behind what we're trying to do. Now it's a matter of finding it. I'm going to leave the list item in here for now. Once I'm done and it looks correct on this panel, all we have to do is bypass it right here and connect to the next part of the definition, and it will run the definition on every panel. Because notice if I put in a panel here, it's got a bunch of things. Oops. But if I connect it to this one, it's only got the one. So that's kind of the beauty of the list item. When you only set it to one item, you can control just one at a time and see what's going to happen to your definition. So remember how we were deconstructing before we used arc? This one uses Brep. Brep stands for boundary representation. When you go in here, you can find this one right here. It looks like a little cylinder. It's like on fire. I don't know why that's the logo, but you're exploding it basically. And so you'll get all of these coming out of it. So if I type connect this across, now you can see it's created the face, the edges, and the vertices. Vertices is another word for points. So that's kind of how they're considered in here. So what I need to do is, just like I did a list item here, I want to know, let's run a list item so we can start identifying these things. So let's just put like 5 in there. And if I look at the edges, and I grab the index here, notice how, let's turn this one off then. Oh, here. See which one's highlighted? I don't know if you can see that very clearly, but it's this top one. And then if I go to the next one, so that's cool, but we don't want to worry about those. We need the points. So instead of connecting that, I connect this one. Now I can see there's points 1 through 4, right? And if you keep going, it's going to just keep circling because it's set to wrap as yes. If you turn that set boolean to false, see now it's like giving you an error because it's going to say that you're too high. See the index, applied index is too high. So you got to come back down because there's only 4, which technically goes to 3. So if you click that guy, once you hit 3, that's it. So 0 is the bottom left, 1 is bottom right, 2 and 4. So we have the points. The next step is just to draw a line. Remember how we drew a line before? So the easiest way to do this is honestly just you tell it line, and you do the one that's create a line between 2 points. And now we need starting point and end point. So if you look here, if we want to grab that guy, here's point 0. We can do this a bunch of times. If I move these guys, I can copy this. And now I have 4 points, right? So this one, they're all set to 0 right now. But if I make this one 1, this one 2, and this one 3, now I have that point, that point, that point, that point, right? And right now it's just highlighting one panel. Remember, we did the list item. But as soon as I disconnect list item and plug it straight into there, deconstruct boundary representation, it's going to blow the same thing all the way through every single panel. So just because right now it looks like we're doing a lot of work, remember this is going to apply to 100 panels at once we disconnect this guy. So this right now is just applying that logic to only one panel because we've told it to do that for now. So this is a good strategy because if you can make it work at the local scale of one panel, then you know it will work at all panels. Sometimes you're trying to figure it out, and when you look at this, and I'll show you what this looks like once you've started doing it to all panels, it's hard to know what's going on because there's so many lines going everywhere. You're like, oh, it looks right, but in reality it could have been reversed, and it's just the way it tiles. When you see it, it looks like something and it doesn't work. Or it might look correct, but then once you tile it, you're like, wait a minute, that's not what I wanted. So now I just need to create this from that guy. So which one does that need to connect to? This one, right? So it's not this one, but it's that one. So if I do this, boom, there you go. We got the line. Now we can do the same thing, except now we connect it to that guy and this guy. So see what we're doing? We found an edge or a surface, we exploded it so that we could actually look at the individual lines, and then we're basically just crisscrossing them here using that logic of 0 to 2, 1 to 3. Does that make sense? And now once we have a line, what can we do to it to give it thickness? Yeah, you can use the pipe command. And what's cool with this one is you could keep it so that it's like that. If you wanted to, we can put both. If you hold shift, so it grabs both. Or if you wanted to control these differently, we can put like different amounts to these. So that's probably like huge. So here's something that's neat. Right now I'm noticing this is like pretty small. So I can turn my surface back on and just really like crank this thing huge. Oops. And notice it still kept the definition. It didn't break the definition. So it's always going to run. And then what's really cool, I'll show you later, we can then just take the same definition which we're creating today to make a Diagrid, and if you save it, you can always open this up and then just remember at the beginning we made that weird shape and we said set one surface. You can create any sort of shape, open up this definition, set that shape to that surface, and then it just creates it on there. Or you can use the thing I'll show you later and do it in like 2 steps. But once you've created definition, it's created. It's not like it's gone and you have to repeat it every time you do this. So you just have to define it a little bit different. So you have that guy, and then here we could apply a different radius to the other members. Let's say like you wanted to highlight certain elements, or you wanted some more creativity. You could do it this way, or you could set a series so that it grows as you go around the building. I don't know, there's a lot of ways you could do it. But now let's say that looks good, 7 and 3. Let's go back, and right here where we had this, let's just bypass it and say connect that across. And now if we zoom out, you can see how it's gone through the whole thing and created that structure for us. And the best thing is, since we used the panel to create those points, we're hitting the edge of every single panel. So where it would need to have a support, the column or that beam or whatever it is, you don't have to pipe them. You could have extruded it or offset it and made it like a beam instead of like a round tube if you wanted to. You could also put like, you could create a definition to create a truss. So you could easily like take that line that we made and told it like offset down, like offset curve, and then told it to cross them vertically that way. Instead of connecting across on the panel, you can do down and then cross that way, and then it's basically creating like a space frame. There's a million ways you could do it, and that's all that these other tools I'm going to show you will do. They're just already set up to do that automatically. The benefit to some of those plugins is that you can quickly get results if you're just trying a basic sort of thing, but if they don't work when you apply it to your kind of shapes or forms or whatever it is trying to do, then they don't give you a lot of flexibility. Sometimes there's just like an input and you just drag it back and forth. So being able to kind of make your own definition when you need to will always give you more control. It's like being able to pick what, like if you're buying a bunch of markers and you go to like the art store, you can pick out the individual markers that you want, or you can buy like the jumbo pack that comes with like bright pink, bright yellow, bright blue, and then you got those, but it doesn't give you control of selecting exactly what shade you want. So think of them that way. So it's a trade-off, flexibility for speed, basically, convenience for control. Some of them give you a lot of control. So this, what's really neat about it now is I can tell my definition, you know what, I'm going to make a shape. So let's grab like, I like doing these because they're like a weird shape and they end up looking kind of cool. Kind of looks like a blimp. And then let's try rotating it. That doesn't look like it's in the right axis, but it was supposed to be. There we go. So I'm going to make this into that Norman Foster building in like one click. Ready? You just go back to the beginning. We could have used this guy. Oops. Original panel. I'm going to click this, right click, set one surface and tell it that guy, and there you go. Now I can hide that. And if you want it to look more, let's hide this, hide those. So if you want more panels, how will we get more panels? You go back to when we subdivided the surface, right? So if we add them in this direction, so you start getting more, or you can add more in that direction. So if this was actually your building, you could control that to be either like your floor to floor height, or double your floor to floor height so that it goes every 2 floors, or you could do half your floor to floor height so you get a full cross in between. So depending like what it is you're trying to do, this gives you a ton of flexibility, and it looks kind of cool at the top. Excuse me. You guys have any questions on that part so far? Does it make sense? So this is super helpful when you're starting to make, especially like any sort of like curved shape or anything like that, where it's not as simple as just creating a square structure and just arraying it down. That's where Grasshopper and Rhino really start to like pull away from others, like SketchUp or just traditional hand modeling, because it's way easier to do it this way. And it's kind of like what it's one of its strongest points is. What's going on here? For some reason it doesn't like it, but that guy's actually working, so he's got to chill out. There's probably, oh, I know what it is. There's probably panels up here that only have 3. Because they're triangles at the top. See, these guys don't have it. There you go, see? So maybe we beef up these ones to make up for it. And then let's say you needed to, it kind of looks like a Fabergé egg. If you wanted to change your form, we can bring back this guy, and then maybe we make it more squared in that direction. And that's it. It's all it takes. It's going to update. The definition is referencing that form, and then it's going to do that. So when you show this to your professor and then they're like, no, like I need to change it, or if you need to do a bunch of design options, you can do that, bake it, make another shape, bake that one. Let's say you wanted to actually put a sphere at each of those like nodes. How could we do that? A sphere there. So let's make these a little bit closer. So see where they cross? Let's say you're like, oh, I want to put a little sphere there. So where are those points? We're getting those, we're identifying individual ones here, right? But they all come out of right there, vertices, right? So if I come here and type in sphere, and then it says base and then radius, and I do that, now I'm going to get a little ball at every single one of these. That's why it's not responding, because it's creating 1,000 of them. Hopefully it doesn't crash. This is one of those where you could either like temporarily pause the definition by like disabling one of them, or you can go up here and tell it not to like automatically run, or you can use that list item and just test it on one area. So it's thinking.
What if you only want half of the here?
Like if you wanted just the bottom half,
Yes.
you could, there's lots of ways you could do that. You could, come on. Are you saying only half of it to have the structure, or the whole shape to only be half?
Should I have just started with
You could.
one shape?
Yep. You could do that. Would probably be the easiest. Like you could start off and have that be the initial form. If you wanted to, like where it can get more tricky is, let's say this is just like we were doing earlier when we were moving those spheres. Remember we were trying to move only some of the spheres. Let's say I wanted this to go all the way up, and then along the entry of the building, I wanted that whole row of digrids to be like basically instead of one diamond, as big as 4 diamonds. So like bigger, you know? Then we would have to go in and pull out, before we created this step where we crossed all of them, we would have to somehow remove those individual panels from that structure. Does that make sense? So that before it does this, it would start to like panelize everything, but those are left out.
So you're telling it, don't do this.
Right, and then the result would be that those panels would look like 4 because it's avoiding them. And then you could technically identify the panels that are on the edge and make that like a much beefier structure. Or we could tell it somehow determine those, and that's where it just comes down to understanding the data and then running through it to find a pattern that will actually grab them. And sometimes it's a matter of you have to run the list to see like, okay, that's panel 10, and you go around and say, okay, this one's 15, and then you go to the next one, it's 20, so then you realize it's every 5, and then you use that. You can also like step it. So you could say like, give me all the even panels, and then once you've distributed only even panels, then you take out like 10 through 11, or floors 10 through 20. And then from that, you might do something to that amount. So you can always keep filtering the data down to get what you need. It's just going to be a matter of like, depending how complicated you want to make it, is how detailed you'll have to get. But a lot of times, if you just work it out, it ends up being like extremely simple math. Like it'll be like every 4th one or every 20, and then you just it's never going to be like, or you could write, I mean, like as detailed as you want. You could write like a whole like logarithmic equation to get like the thing that you needed, and then but you could do this like linearly, like saying like every 10th, or you could do like x squared, so you get like some cool spiral happening, and you can do like all kinds of things where when you're done you're like, man, how'd you do that? And then you look at it and it's like 3 little components that ran, and it was all how you controlled which things got selected. And it's not, a lot of times just by controlling that, you'll have so much diversity that it's like, let's say you wanted to put like gardens on all your floors and rotate them around like this building is in real life, then you could do that. You just have to find a way to count them so that those get left out, and then they get either a larger structure or more glass. Or you could use this to then have 2 different types of glass. Like you could say every 5th one gets a green glass and every 10th one gets yellow glass or whatever, and then you could look at it as it goes around the building doing that. So there's a ton of ways you could control it. Another really cool thing you can do with these is, let me show you this plugin first. So this one's called Lunchbox, and Lunchbox will become your best friend because it can do this big definition that we just wrote. Let me make a new document so it's gone now, and we can bring back our little tower. If you just grab here, Diagrid Structure, and bring it down, so this is equivalent to, right, so if I were to grab this one, so see here we have all of this. What I can do with this, which is kind of neat, is, let me show you. I can move these out, and then I'm going to grab all the stuff and leave out the original inputs and what came out, and then I'm going to right click. I'm going to go edit and then cluster. Oh, you can also do this by hitting the space bar. Come on. Or there. you right click in space and you type in cluster, it will bring them all down into one. And when you look, it just says cluster. And if you double click it, you go like inside it. So it's like you're in the group and it's like a little box. And you can edit stuff in here, you can adjust it, and then you double click this box to get out. I think it's rerunning that sphere thing, so I should probably take that out. But what that lets you do is basically like group larger parts of your definition into one little component, and as long as you left out, that's the one caveat. If you don't have, let's say like it ends with like a bunch of outputs, but you haven't connected them to anything, once you cluster them, it will give you that jagged edge on the right side that doesn't let you connect anything to it. So you at least need to leave something out of it so that it knows you're trying to pull stuff out. And then this becomes kind of like a custom component, because you can name this whatever you want. Let me just delete this guy. Now I can go back, see, and if you click this, it says save and close, or you light the box on fire and then you discard and close. So it's basically like saying I don't want to do it, or you can return to parent. So I'm going to just say save and close. And then if you right click this, you can rename this. So this could be called Diagrid. There's no way that's spelled right. Diagrid Structure. And now look, we have surface, domain, U count, V count, and out of it we get the two lines. Which if we wanted to, we could have done something else with these, right? So this is up to you, so you can decide what you think should go in there. And the crazy thing is now I can just hit Control C and Control V, and I have like a whole nother one. And it's like a million things, but like it's just one little component. So that's where it's like you realize you can do a lot of stuff with this. And then on the outside, it still will work perfectly. So it needs this, and then it needs your surface. So the surface and the domain, and see it's grabbed everywhere it was pulling an input from the outside, and it's created it as an input on the left side of this little cluster. So sometimes you'll download a definition, like I'll show you some websites where you can go and you can find other people's like definition. People will upload and be like, oh man, look, this one will take any shape and then lay it out on panels so that you can laser cut it, and then it flattens everything and it numbers it for you, and you get it and it looks like this, and you're like, oh man, but I need to change one setting, and like there is no way to change it, but it's actually, you're like, okay, they use Diagrid Structure, and you type it in and it's not even a real thing because it's a cluster, even though it looks like a component, and when you highlight it, you'll see that. But if you don't know what this is, like it doesn't mean anything to you. So I see that happen a lot where people are like, I don't know how they got this. Or they're watching a video and someone has a cluster as part of their definition and they didn't realize it was a cluster. So if you see in a definition some weird stuff, it's always a red flag when it's spelt wrong or it's like got like weird gibberish in it. But if you notice, this will stay active. So I can change this and I just have a couple inputs and outputs, and I'm completely changing what's happening, and it still runs straight through it. So that's almost exactly the same as this. See? Type, what is this? Diagrid type, true. I don't know what that does. It's like, it's true. Okay. But see, that's really similar, but this does the same thing now. We made that one our own, but this one is done and it is part of that. It just has a cool logo. That's the only thing that ours doesn't have, but ours has the whole definition in there. If you look, there's also